Factoring by completing the square is probably the least favorite of all students as far as methods of factoring. And basically, I'll do one, I'm going to do two, but I'll do one where if you can factor, right, equals 0. If you can factor and solve normally, always do that, right? But then if you can't, that's when you have to do this whole completing the square. So this one, this is between you and me, this actually does factor. This would be, I can tell right now, you could do minus 4 plus 2, and that factors to be that. And then solving, you'd have x plus 2 equals 0, right? And then x minus 4 equals 0. I'm going kind of fast because I'm assuming you watched another video on just normal factoring when you have a trinomial. And so this is cool. Everybody's happy. This would be minus 2. So x would be negative 2, and x would be, add 4 to both sides, 4. What happens is when you can't factor, that's when completing the square comes in. So we're going to pretend like we didn't see that that was factorable. So again, you never do completing the square unless you just can't factor it the easy way. That was a fail. So we have x squared minus 2x minus 8 equals 0. So you looked at it, right? You're on like a test and you're like struggling and you're like, dang, you know, I can't factor it normally. Now I have to do the stupid completing the square technique. This is what you would do. So you would look at this and say, because I can't factor it, the negative 8 is really not helpful. So you move it to the other side. That's step 1. Then you'd have x squared minus 2x, leave a gap, and now plus 8, that's equals 8, right? And the reason you leave a gap is you're going to bring a whole new number into the problem, which I realize you think is illegal, but it's not. Does 5 equal 5? Of course it does. I can add whatever I want as long as I do it to both sides. Let's say I said, like, I'm just going to add 2. That seems kind of sketchy. Well, it's not sketchy if I add it to both sides because now it's still true. 7 is 7. So that's the math law that allows me to add whatever I want to both sides. Now the number you add to both sides is super specific. This is where completing the square is like gets annoying. It's always exactly half this guy squared. So what's half of negative 2? Negative 1. What's negative 1 squared? Positive 1. Whatever I do to one side, I immediately have to do to both sides. So now I have this little situation, right? I have x squared minus 2x plus 1 equals 9. I didn't break any laws because I did it to both sides. By picking half this squared, I automatically know for sure that this is going to coincidentally factor out to be a perfect square. So watch this. This comes out to, if I factored this and I spent some time on it and looked at it, it would be x minus 1, x minus 1. Negative 1 times negative 1 is 1, but negative 1 plus negative 1 is negative 2. Do you see how these are matching? That is not an accident. That's like because I did half that squared. This is going to happen every time with completing the square. And because these are identical, look how I can write this. Instead of writing it twice, can't I do this? X minus 1 squared equals 9. It's the same exact thing, right? And this is what you have to do. You have to write it as squared because the next step is like when you're going for the gold. This one, now to solve further, how do I get rid of a squared? You're going to root both sides. So now you have x minus 1 on this side. The root and the squared kill each other. Equals, do not write 3 for that. It's plus or minus 3. The root of 9 is plus or minus 3. Now from there, you're going to add 1 to both sides. In front of that, I'm going to bring it over here. So now you have x equals 1 plus or minus 3. So that would be x equals 1 plus 3 is 4. And then x equals 1 minus 3, negative 2. If you remember when I factored it normally, I got the same answer. So this just proves that completing the square works. Now I'm going to do a lame completing the square where it doesn't come out to these pretty whole numbers, okay? So hang in there. Don't get all annoyed. I know, again, this is like, by far, this is plan Z. Plan A is to just factor it normally. Plan Z is to factor by completing the square. So here's a bad one, okay? What about x squared minus 6x minus 11 equals 0? Okay, now I'm actually not bluffing. This is totally not factorable. Nothing multiplies to be negative 11 and adds to be negative 6. So again, because this is not valuable, I'm going to move him. So we have x squared minus 6x space, key, you learned that from me, equals positive 11 because I added 11, right? Okay, now I'm going to bring in a new number. That number is not random. I'm going to bring in a special number to both sides. And remember, it's half this guy squared. What's half of negative 6? Negative 3 squared plus 9, little Spanish lesson, plus 9 on both sides. Cool? Now, this happens to factor to a perfect square. This is going to be 20 over here. This happens to factor to a perfect square, not by accident because I invented that. And remember, it's always identical, like that. Just a little tip. This guy is always exactly half that guy. All right, so that's x minus 3. So now let's write it the right way. X minus 3 squared equals 20. And now is the cool part where you're going to root both sides. Okay, now you have root. So then you end up with, I'm forcing myself out of the vid, x minus 3 equals plus or minus 20, root 20, excuse me. Plus or minus root 20. Now you add your 3 over, x equals 3 plus or minus root 20. And that is your answer. Yes, I know there's math nerds out there telling me that you can simplify that, but I get it. You can simplify root 20, and that would be 2 root 5, but we're not going to go there. So this is your solution, and that's how you do factoring by completing the square. Remember, if you're having a hard time with Algebra 2 at your local high school, you can take this online at Silicon Valley High School, and the credits will then be sent back to the registrar at your school. Thanks.